Hello, and welcome to WISA's third webinar, WISA Talks, Environmental Initiatives in Aviation. I'm Dr. Suzanne Kearns. I am the founding director of WISA. Thank you to our community, industry and government partners, students, staff, faculty, and all of our friends who have joined us today. To begin with, I'd like to acknowledge the University of Waterloo is situated on the Haldeman Tract, land that was promised to the Six Nations of the Grand River, and is the traditional territory of the Neutral, Anishinaabe, and Haudenosaunee peoples. We also acknowledge with respect the diverse histories and cultures of all Indigenous peoples of this country. Acknowledging reminds us that our great standard of living is directly related to the resources and friendship of Indigenous peoples. I encourage you to take a moment and acknowledge the traditional territory that you are residing on today. The University of Waterloo and WISA value the diverse and intersectional identities of its students, faculty, staff, and partners. We regard equity and diversity as an integral part of academic excellence and ask for all conduct today to embrace these values of equity, anti-racism, and inclusion. If you have questions during the event, please type those within the Q&A tool. WISA is a research institute at the University of Waterloo with a mission to be the world's leading hub for sustainable aeronautical research, technology, and education. The core of our work is to foster interdisciplinary research, cross-sector partnerships, and experiential learning towards a sustainable future for the air transport sector. Thank you for joining us for our WISA Talks webinar, within which we bring together a panel of industry and academic leaders for a deep dive into sustainability challenges being faced within the air transport sector. At WISA, we consider three pillars of sustainability: social, economic, and environmental. In previous WISA Talks webinars, we explored evidence-based training and analytics and optimization, key elements of social and economic sustainability. Next month, we will have another WISA Talks event discussing high-level future directions in aeronautical sustainability. In today's discussion, we will explore various environmental initiatives in the air sector. I'm excited to learn more about what is being done within industry and academia to reduce carbon emissions and minimize the environmental impact of air operations. I would now love to turn the webinar over to our moderator, WISA Associate Director leading the environmental pillar of sustainability, Dr. Paul Parker. Dr. Parker is a professor in the Faculty of Environment. Over to you.
Thank you, Dr. Kearns, for the introduction. Hello, everyone. As Suzanne just said, I'm Dr. Paul Parker, the Associate Director for Environment here at WISA, and I'll be the moderator for the webinar today. But I'd like to start with a special welcome to everybody that's joined us online. So thank you for joining us. We've got a great lineup of speakers, lots of ideas to share, and we hope it stimulates many conversations. Environmental initiatives is a broad field, so we want to start a number of conversations, knowing that each one could easily fill a full webinar on its own, and we'll dive deeper in later ones. But we've asked several speakers to be concise and make their presentations in just 5 minutes, although we know we could easily talk to each one for an hour. Our panelists, I'd like to briefly introduce. Today, we are joined by our industry partners with Kevin Bruce, Director of Quality and Airworthiness from Diamond Aircraft, Xianguo Clarke, Co-founder and Chief Innovation Officer for Universal Hydrogen, Catherine Conway, Director and CEO of Aero, Chelsea Ann Edwards, the First Officer with Sunwing Airlines. They're joined with our researchers. Costa Kapsis is a professor in the Civil and Engineering Department, looking at engineering, architectural engineering. Xianguo Li, a professor in mechanical and mechatronics engineering. And Gurpreet Singh, a doctoral candidate in sustainability management. I'd like to just briefly show a slide coming the diverse topics of what's the motivation for this theme today. And this is my motivation. This is that very rapid growth that we see in the carbon dioxide emissions from aviation. And so this has now reached over 1 billion tons in 2018 and anticipated to grow at over 4% per annum. The blue line at the bottom is the percentage line. And here, of course, we say, well, it's not that bad. It's only 2% of emissions. Well, then actually, it's 2% of carbon, it's 2.5 of CO2. But if we look at the effective radiative forcing, because our emissions are at altitude for many of them, it's 3.5%. And so it is a substantial issue. Great to see the industry taking action with the Air Transport Action Group, having a target of net zero by 2050. Next slide. I also like looking behind the slide to say, yes, we see that rapid rise, but if you look at the red line, that's the improved performance. Actually, aviation has become much more efficient over time. The actual growth curve is shown by the dotted line, how many seat kilometers there are, or the solid line of the revenue passenger kilometers. So we see even faster growth, but our improved efficiency is not enough to offset that rapid growth. So we have to decarbonize. Next slide, how are we going to do that? So I like this idea that there is no single answer. So the Roland Berger roadmap is an example of the multiple different technologies that can be used. I won't go through this in detail any more than I agree with the assessment that we need multiple actions to take place. And so this is a good reference document to look at some of those options that we have. Next slide. Here, I like it where they're emphasizing we need to look at the continuous improvements that we've made in operations and continue to do so. We need better air traffic control, trajectory optimization. In terms of propulsion systems, I like how they look again at multiple answers, saying, sure, for the first 1,500 kilometers, fully electric. Beyond that, up to 6,000 hybrid electric with SAF. And then over that, looking at power to liquid SAFs as their range of new technologies that are required and looking at exciting investment opportunities. Of course, we need research to improve that. We need better understanding of climate science. And of course, we need to compensate any residuals. Next. Here is that pathway, and it suggests the contribution that each component can make. For example, having 50% savings with trajectory optimization, 15% savings with electric aircraft, another 15% with hybrid, etc. So this is the agenda that we have, multiple conversations. Let's go to our panelists and start looking at these different slices of that roadmap to true zero. I'd like to start by first introducing Catherine Conway. Catherine, thank you as one of the 3 pilots setting a world record flight distance with electric aircraft. We thought it would be great to learn about you pushing the boundaries, but I thought I would also share, in addition to your official roles as Director and CEO at Aero, that you are a very successful competition glider pilot, being on the Australian women's team at the World Championships, and therefore understanding that landscape that you're flying over to try to stretch that world record distance. So thank you for joining us today, Catherine.
Thank you, Paul. Thank you for inviting me to join across the globe from here in South Australia. Well, I should first confess that my background is not aviation. My career has actually been in defence radar, radio communications, and then later telecommunications. And as I head towards retirement, I find myself more and more drawn to my hobby, which started off as gliding and moved into flying powered aircraft up to and including the lovely PC-12 that you see there in my picture. But what I'd like to talk to you today is a little bit about Aviate and how we journeyed to join Barry into the electric record attempt. So Aviate is a flying school that I founded to be a little bit different. It was based on the Super Demona motor glider with the aim that the motor glider could teach commercial pilots a lot about feel of flying, emergency handling procedures, and the sort of things that they really don't get out of a high-paced commercial flying course. As part of that, I've also done consulting work on the side, including helping people get gliders on the register, and that's what started my electric journey. a friend of mine had a Taurus, a Pipistrel Taurus electric that he wanted to base in Tasmania. So we brought that into the country, put it on the register for him, and then we both went to Pipistrel to do the electric aircraft training. So I was lucky enough to be factory trained on the electric system in the Alpha and the Taurus, which was both aircraft covered by the course, as well as flight training with the factory test pilot. So when the Pipistrel Alpha arrived at our local airport at Parafield in South Australia, and I met the owner and he was showing it to me, and he said, now I have to figure out how I'm going to get it flying and maintained. And I said, well, I'm factory trained in both. So that kind of got me involved in the project. And then he told me, Barry Rogers told me that his dream was to break the electric world record. Now, Barry is an early adopter of the technology. He understood that it's not really the end game yet, but somebody has to make a start. He's an ex-airport manager, so he is very passionate about getting charging stations and getting the airport managers to start thinking about the infrastructure that is required to support electric aviation. And these are the background things that we really need to think about, as well as the aeroplanes themselves. So we moved my flying school and started the process into getting an accreditation to become an RAOS, which is the Light Sport Aircraft Accreditation. And we started doing some training with the Alpha Electro to get an understanding of what it was like to actually teach in a fully electric aeroplane. And there were a number of things that we did have to modify around the airport. One of those things was the training area. It used to take 20 minutes to transit to the training area, or probably 10 to 15 in a DA40, which is a little faster. And when you've got maybe 45 to an hour of electric endurance, you really can't go to the training area, do anything meaningful, and turn around and come back. So we had to negotiate for our own little training area closer to the airport on the other side, on the other departure, and get the tower guys to get their heads around that electric aircraft, when they stop at the hold point, their propeller stops. So they don't have to talk to us about worrying about that. Anyway, after we got some experience with the training, we decided it was time to try the electric attempt, record attempt. So we flew, as you can see on the slide there, 1350 kilometres, 750 nautical miles. We had 5 flying days. We were interrupted by rain. Despite the look on that terrain, it does rain occasionally. We found that the performance of the aircraft was not as good in a straight line as it was in the circuit, where it could regenerate on landing. And we had to do a lot of testing beforehand to determine the best speed to fly. So hence the gliding background came in useful in order to get the greatest range. And of course, we made best use of available terrain, such as ridges or weather with cloud streets and things like that to help extend that. Can we go to the next slide? I think one of the greatest benefits, as you can see in that picture, is that we got to bring aviation to some little outback schools and probably made quite an impression on these children who have had the opportunity to see the first electric aeroplane. We ran into some problems. Some very cold weather in the evening made it harder to charge the batteries. In fact, the BMS charging system shut down and wouldn't charge on that night. The battery health degraded quicker than we thought. So battery health as opposed to state of charge. And given that Tesla's used the same batteries, we think that perhaps the battery management system needs some more work on this aircraft. So all in all, it was a great 5 days. We finished it, so it's also the first light sport aircraft ever to land at Adelaide International Airport, and ended up with with a record that was very quickly, I think, broken afterwards by some guys in New Zealand.
Well, congratulations, Catherine. Again, it's great to have, of course, set a record, but records are meant to be broken. But congratulations for pushing the frontier there. I'd like to move on to our next speaker now, Chelsea Ann Edwards. Chelsea Ann, of course, I love you bring both the profession, the industry of aviation to the university and being excellent in both. So Chelsea Ann, please share with us your insights.
Hello, everyone. My name is Chelsea Ann Edwards. Today, I'll be talking about a paper that I worked on with Dr. Paul Parker entitled Flight School Perceptions of Electric Planes for Training. And I'll also briefly talk about the environmental procedures at Sunwing. The paper we developed involved a survey where we asked different members of flight schools, such as student pilots, flight instructors, managers, and flight center owners, what their thoughts and opinions are of using electric planes for flight training. In total, we asked 186 flight school members what they thought about the technology. Though the majority of members claimed to have low to no knowledge on e-planes, 84% responded that they are very interested in learning to fly an e-plane. We found that the top drivers for the flight school members to want to fly e-planes were that reduced emissions were expected and that reduced cost of training was expected. The tables I have here outline these possible savings. For example, one student's PPL or private pilot's license takes at least 45 hours to complete. In a typical plane that a student would use, such as the Cessna 152, the fuel cost alone would be around $2,000. And since prices of fuel have increased since then, it'll be an even larger amount now. If an e-plane such as the Velis Electro by Pipistrel is used, the fuel cost is around $135 total. This is representing approximately $3 per hour charging cost. Therefore, this results in savings to the student and the flight center of at least $1,800 in fuel costs. Also, by using the electric plane with no in-flight emissions, there is a savings of 2.3 tons of CO2 per PPL student. While I was doing this research, I created a data sheet with the ages of all the aircraft used in flight training centers across the country. It turns out that over 60% of all single engine aircraft in training centers in Canada are more than 43 years old. The table on the bottom shows what the emission savings from flight training could be if some of these were replaced with electric planes. If we replaced all those aircraft that are over 43 years old, we would see emission savings each year of around 22 kilotons of CO2. With these amazing emissions and cost savings, it makes sense that these are the biggest drivers for flight center members to want to fly e-planes. In terms of reasons they have for not wanting to fly e-planes, the trends were not as strong. However, there was a clear concern with the battery endurance. As this plane here has only a range of 50 minutes, it does make sense that at this point, battery does remain the biggest concern. Other details we found in the study were that every group, whereas that student pilots, flight instructors, or managers, or others, claimed to have less guilt from their carbon emissions from flight training than their emissions in general. Also, we conducted a gender analysis to see if there were any differences between males and females. We found that males claimed a much higher level of knowledge in the technology than females. However, both groups had very similar levels of trust and interest in learning to fly e-planes. Additionally, females found that the reduction of emissions was a more important reason for them to want to fly e-planes than the males, and they also reported higher levels of mission skills, both in general and for flight training. So now I will briefly touch on the environmental procedures at Sunwing. Though Sunwing has not yet participated in biojet projects, they participate in other initiatives such as using an efficient fleet and operating using more efficient routing. Sunwing has an efficient fleet, including the 737 MAX 8, which are 14% more fuel efficient and can have CO2 emission savings of up to 20% in comparison to the original 737 engines. In addition, these engines emit nitrous oxide emissions that are 50% less than the standard set by the International Civil Aviation Organization, or ICAO. The routing procedures include use of performance-based navigation, such as use of RNP or required navigation performance approaches. These approaches are more direct and reduce emissions by use of more productive routing. The chart on the right is an example of an RNP approach into Edmonton Airport. In line with that technique is use of what are called continuous descent approaches. These approaches are ideally minimal drag and minimal thrust, which reduces fuel burn, saves emissions, and reduces noise. Finally, Sunwing participates in airport collaborative decision-making wherever this method is used. Essentially, this technique stops traffic jams of aircraft waiting to take off by systematically setting pushback and start times for each aircraft. Toronto was just starting to implement this procedure in the beginning of 2020. However, I do have experience when this was used in Amsterdam Schiphol Airport. Though Amsterdam is one of the busiest and largest airports in the world, this system would work like clockwork, and I couldn't believe it when there's never any lines to take off. When used effectively, this system minimizes engine on time on the ground, therefore reducing wasteful emissions. I'm hoping in the future that Sunwing and other airlines become more involved in projects such as the use of biojet, but for now, these procedures do help to limit unnecessary emissions from airlines. Thank you very much, and I welcome any questions at the end.
Thank you, Chelsea Ann, and perfect timing as well. Next, we want to move on to the industry representing here Kevin Bruce. Kevin, you're hearing all of these electric aviation stories. We look forward to hearing the new initiatives you have underway at Diamond.
Oh, yeah, sure. Welcome, everybody. I'm glad to be here and be able to talk to you about what Diamond is doing in the industry right now. And I guess I could start where has Diamond been? And I think it's a good picture to show because the history of the company actually has been long involved in looking at ways to reduce our impact on the environment in various different arenas. And we started back actually, in a big way in 2002. When we introduced the very first aircraft that used a diesel engine, and it automatically reduced the use of fuel by 30% just because of the nature of the diesel engine. Now we call it a diesel engine because its heritage is a Mercedes-based engine, but it actually runs on Jet A. It doesn't run on diesel itself; it runs on Jet A fuel. So that was our first foray into the process. So just our standard engines that we used before, so our standard Lycoming Air Continental engine, we were able to see a reduction in consumption by 30% or better, depending upon how you flew it, and that was a good start. In 2010, we actually conducted the very first flights with algae biofuel, and we were working with EADS out of Europe and other companies that were producing this biofuel using algae and growing the algae themselves in controlled environments. And we did about 100 hours worth of flying on our diesel engines that we had developed, which is also something else that we could talk about as well. That we actually went from one manufacturer of the diesel engine to developing our own engines, and the company is now called Austro Engines. Back in 2011, we started our first program in looking at electric aircraft, and we flew the first hybrid electric drive system that was in serial. And when we talk about in serial, it means is that you can power the propeller by the electric engine, but it's backed up by an electric or a gas generator. We did a lot of flying around with that and had some success with that. But we chose to do some modifications to it and came up with what we referred to as our E-Star 2, which was our second attempt at an electric aircraft, and it improved on our original design and the battery design and installation, and helped us move forward into the next stage. And there you go. There's the picture of it. So one of the biggest issues we have with obviously with battery technology is that its power to weight ratio, which is very high, and so the ability to fly an aircraft with the battery systems becomes limited due to the weight. And anybody who is involved in aircraft design knows that weight is always a problem, and you always are heavier than you want to be. So there's a lot of work that had to be done in order to look at a reduction in weight from the battery system standpoint. In 2018, we converted our DA-40 aircraft into a twin-engine hybrid aircraft. So we used the Austro diesel engine up front to be the generator, and we attached two 75 kilowatt engines on either side of the nose of the aircraft. And it was a proof of concept airplane to see how the technology was evolving since we did our last aircraft in 2013. And again, the battery technology yet wasn't at a place where it was a viable product. It was still too heavy. It was still too short a time. And there was other issues in terms of the battery technology from a safety aspect that we always have to account for in an aircraft design system. So that's the past and where we went to. And currently, we are on our path towards a fully electric aircraft, and it will be a new version of our DA-40 aircraft, which you see here in the picture. And we are partnering with a battery system developer out of the US to do this, and they are developing a full charging network system, as you can see in the picture here. And we plan to bring it into service in the end of 2023. To be honest about this, the flight time of this aircraft is going to be 90 minutes in total. But when you think about VFR reserves that you have to have on board, which is 30 minutes, you're going to get about an hour's worth of flight. But from many of our customers that we talk to, this is a perfect airplane that they can transition from their current DA-40 platforms to this electric aircraft for primary training, and when most of the training is done in the circuit, as was discussed previously. So that's where we've been. Where we're going, here's let's take a quick look at this. We're looking at sustainable aviation fuel. Now, it's something to look at, but there are some downsides to it because we're really not reducing emissions. What you're basically doing is recycling it potentially. There's also hydrogen fuel that's a potential to look at, but there's other areas that we have to get into besides just reduction of use of fossil fuels. We have to look at the life cycle of materials, the energy we reduce or we use to produce the product, and the overall environmental impact, which changes our climate as well in terms of our manufacturing. We have to think about that. And in the end, as we do this, we also have to continue to ask ourselves, what is real sustainability? Thank you.
Excellent. Thank you, Kevin. And thank you for widening our discussion and for raising that hydrogen topic, because that makes the perfect segue to our next speaker. Xianguo Li, of course, is a hydrogen fuel cell specialist and an engineer here for decades, national leader in the field. And Xianguo, great to have you applying your knowledge to aviation now.
Well, hello, everybody. It's nice to to get to this newly found institute and looking at how the propulsion stuff we've been working on and can be applied to deal with aviation emission issues. Now, at the beginning, I think you have seen some of the emission data from Paul's presentation. I'm going to repeat some of these just to clean up so that we can give an idea why technologically we have kind of a lot of challenge to do it for clean aviation. And if you're looking on the greenhouse gas emission equivalent total, it has been increasing, going back for decades, and it's projected to continue to grow. The one I'm having here is a reference about 4% per annual increase, and while Paul's data showing earlier predict 4.3% increase, so still within the margin of error. But you see that the change is going up very quickly for the total emission from aviation industry. And if you even consider, say, a technological improvement on a 2% improvement per year basis, that if you're looking at by year 2050, you still have kind of emission being doubled compared to where we are now. And you may wondering why this emission only consider a few percent of total emission from all sectors combined together, become an issue here. So Paul's presentation already mentioned that, and I want to highlight that because the emission from airplane is at a high altitude and is going to have a bigger impact than the emission on the ground level. which have to travel high into the atmosphere before the impact become more significant. So in that sense, that all the emission from airplane at a higher altitude, the impact is about 2 to 4 times as large as those emitted on the ground level. And you see that in order to reach zero emission or net zero target by year 2050, we have to do something drastic now to turn around the total emissions. So with that, I want to really more focus on the technological aspect of it. So can I go to next page? So that in terms of propulsion technology, we could have a few ways to do. One is to using a new fuels, which has, say, no emissions when you use on airplane. And so that is something we call sustainable aviation fuels. The first thing that we can look at is biofuels that you can make from biomass, from agricultural residuals, forest residuals, and so on. The biofuel has one challenge is that its property is quite different from petrol fuel. And you have to modify existing engines to make it work properly. And the secondary fuel using a synthetic fuel, essentially you capture carbon dioxide from air and using a renewable source to make hydrogen. Then you synthesize this, petrol oil type of fuel for aviation, which is easier said than done. In fact, with the cost estimate, synthetic fuel going to be more costly compared with using biofuel or just using hydrogen directly because you have hydrogen. Now, if you look at the hydrogen, hydrogen is clean when it's burned. First of all, there's no carbon in it. Of course, it's going to form other, like NOx and water vapors. So if you're looking on the bottom, table, that the emission, if you look on the traditional jet fuel, or you may say kerosene category of fuel, there's a CO2 emission and the NOx emission in terms of its climate change impact is equivalent to CO2, 100%, and water vapor is 10%, and then the contrails. These are the cloud type of formation in the atmosphere going to cost another 100%. So the total impact is 300 to 400%, in fact. So we're using a bit conservative in this table, 310. Now, if you're using synthetic fuel, essentially you don't have CO2, but NOx, since if you're using the traditional technology for burning, NOx is still there, water vapor is still there. In fact, if you're using that, you cannot really avoid that. And then the contrails is there. So that's almost 200% of equivalent CO2 emission. And if you're using hydrogen turbine, and it's similar, you're getting a little bit less, but still is over 100%. And if you're using hydrogen fuel cell and electrify aviations, and you can reduce to about 55% if you emit water vapor to the atmosphere. But since the fuel operation temperature is less than 100 Celsius degree, and you can actually capture water for hot water use on plane, and that you will be able to make a truly zero emissions. And so that a fuel cell powered airplane has been demonstrated in the United States, Russia, Europe, and so on. But they've been a bit on and off in the past. And starting last year, the European has this Green Deal plan to make a hydrogen powered fuel cell airplane and certify for commercial operation by the year 2035, because the new technology for aviation take about 15 to 20 years to mature, and certification is one of the biggest issues because we don't know what to certify, have no experience in it. So that being said, I think I could stop here and we can talk more on the technological aspect as well. So thank you.
Thank you, Xianguo. That's very, very good. And of course, it's nice to move from, in theory, what it would be like to move to hydrogen, to next turn to JP Clarke, of course, a professor at the University of Texas at Austin and the co-founder of Universal Hydrogen, which we're very interested in hearing about your solution, JP.
Thank you very much, Paul. I will say that it was kind of fun to hear about from Chelsea Ann about CDAs, because I actually was one of the proponents and the pioneers in the CDAs from years back. So I guess
Excellent.
I say that
I
to
love
say
the positive reinforcement.
I say that to say this, that having worked for much of my career on the one part of that 15% bucket of your set of things, about 3 years ago, I got more like 2.5 years ago, I got aligned with some colleagues, one of them my former student and my former boss when I took time off to go and work at United Technologies. And we were having dinner and we were trying to figure out how to deal with what we just heard, the fact that it takes forever in aviation to get anything done. And how do we enable green aviation in time for the Paris Agreement goals, targets of 2050. And so we were sitting around thinking about what was the right fuel, and everybody says, oh, well, you know, from a specific energy perspective, hydrogen is amazing. Obviously, we have to contain with the volume issues and we have to keep it at high pressure and all that stuff. But then there's also, how do we get it from where we can produce it greenly, i.e. with green electrons, to the places that we need to consume it, at airports and into aircraft. And so next slide, please. What we came up with was the idea of literally creating the equivalent of modules or batteries filled with hydrogen, high pressure hydrogen at 850 bar and liquid hydrogen in an uncooled but heavily insulated, well insulated capsules in a modular fashion. And so we did some back of the envelope calculations as academic, well, I did some back of the envelope calculations as academics want to do. And I looked at my colleagues and I said, I think we can do it. And I think it'll make a huge difference because people forget how long it took for us to build out the existing infrastructure we have for moving gas and petrol and all different kind of fluids around the system. It took a long while, and it took the excess profits of all the oil companies, Exxon, Mobil, Shell, all of those companies, and many, many years to build out the gas station infrastructure, the distribution infrastructure, the pipeline infrastructure. And we really don't have that outlandish or outside excess profits lying around and the time to build all of that stuff. So we should take advantage of the existing infrastructure that we have, which is the intermodal freight transportation system. So as you can see on the chart, we basically have a complete recyclable system where you have modules, you fill them up with hydrogen, either in gaseous or liquid form at a place like a wind farm or a hydroelectric dam. You transport it by the existing intermodal freight transportation system. You basically have them at the airports and you put them into the aircraft, like on the right. And then when you finish using them, you basically ship them back and refill them. So all things in a recycled mode. Next slide, please. And so to get this done, we had to do some invention because the existing storage systems for gaseous hydrogen, especially, and don't have the kind of mass fraction that you need. And so we went and took what I refer to as an axiomatic approach to the design, which is based on the principles of axiomatic design, where we decided to build the capsules that stay in this module, and the module is on the bottom right there. It's as a frame with 2 capsules, sized to fit transversely in a -8 or a ATR. And each of those capsules would be containing the hydrogen, i.e. impermeable to the hydrogen, would deal with the pressure from the pressurization of the hydrogen, and also deal with abrasion. And then the actual frame would be carried the actual crash loads. Just same way like you put an egg in a truss, and you drop it and you preserve, and the egg is, and everything just deforms and the egg remains perfectly good. That's the same approach that we're taking here. So we're just making up basically a layered approach where each layer satisfies one function. And that's the whole principle of axiomatic design. So we're in the process of building that, and we actually have a solution that will give us a mass fraction of around 17%. So hydrogen over hydrogen plus structure. And then we'll be building modules for not only regional, but for urban air mobility, as well as single aisle, and for other verticals too, trucking, marine, and rail. And the other thing that we're doing, we're building a powertrain, and we just announced that we have a 1 megawatt powertrain, that test bed that we just completed. And our intent is to get it running and going through its paces and doing a flight test later this year. And that's it.
Excellent. Thank you, JP. I love the idea that it's so important to standardize. And so I love your standardized units. And then, of course, it can be applied in multiple different transport needs. So great idea. So lots of exciting ideas coming in aviation. But because we have that sustainable aeronautics title, we also wanted to look beyond into aerospace. And it gives me great pleasure to introduce Gurpreet Singh now, who, yes, he works in the industry, but has also decided to come back to do his PhD and on space sustainability. And so this is, of course, a very exciting topic. And Gurpreet, take us into what do you mean? What are you finding on space sustainability?
Oh, of course. Thank you, Paul. And thank you, everyone, for being here. My name is Gurpreet Singh. I'm, of course, a PhD student at University of Waterloo. I just started my second year here. I work with Professor Stephen Young at SEED, and Professor Paul Parker is on my PhD committee. I always get great directions from him. I have a background in space science, so really technical, and I work as an engineer in an aerospace company. But now I'm trying to understand the notion of space sustainability, and I'm trying to understand what's happening in the literature as well. So to define what is space sustainability precisely, I don't think it's possible yet, but I don't think that should discourage us from talking about it, right? The way I kind of define space sustainability in my head is to align the system variables such that we can keep using space as a resource indefinitely, but also improving our performance as the day progresses. And why sustainability? Because sustainability management, the theory of it, I think, is the only theory that I've come across which talks about the notion of time in terms of intergenerational equity. For example, we should keep space safe such that the next generations which are coming after us, many of them, can keep using space indefinitely. We should not pollute it too much for them. Next slide, please. All right, so what I'm going to talk about today is just really nice short 2 slides where I'm going to talk about what I've been discovering in the literature. So this first slide here talks about a number of space sustainability publications, like the peer-reviewed journal articles or conference proceedings that explicitly talk about the idea of space sustainability in literature. So this plot here shows a set of 900 papers that I found on Scopus through the efforts of University of Waterloo's library. On the x-axis, I have years here, and it's like about 8 decades, starting from 1960s to all the way up to 2021. 2021, it's capped to just first quarter because that's when I collected my data. On the y-axis, I have frequency, which represents the number of publications that I found on space sustainability for that year. So as you can see, starting from the 1960s, when the space race kind of just started to begin, we don't see a lot of literature focusing on space sustainability. I found 2 papers in 1961 which focus on the idea of space governance, which can connect back to the idea of space sustainability. But with the starting of this century, we can see a big upswing in the number of publications that talk about space sustainability. And out of these 900 publications, about half of them are just published in the last decade. And of course, 2020 being the winner here with publishing about 10% of the literature focusing on space sustainability. So this clearly shows that the encouragement in literature and also in academia that people have started talking about space sustainability, one. Number two, they do think that this is an important topic that everyone should start to worry about or think about. And third, a lot of people have started writing on it, and why shouldn't we jump on that opportunity as well? Next slide, please. All right, this slide shows a word map of the keywords that I found in the literature. So this shows the top 30 keywords, and also, of course, shows the dimensions or the subjects that the literature of space sustainability talks about. Of course, glaringly, space debris can be seen as the biggest topic of interest. About 14% of the papers talk about space debris intentionally, 100%. Followed by space law or space policy. So the way I see this equation is space debris is the biggest problem, and that's what literature is identifying. And space law or space policy is the instrument to resolve that problem. Of course, there are mentions of other great topics as well. For example, the idea of global commons. What if we see space similar to what we see Antarctica as, or the oceans as? The idea of governance, the idea of colonizing Mars. What have we learned colonizing Earth, and then how can we extrapolate that to space? All these cool ideas, but then space debris is of course the biggest one. I think the take-home message from me to the entire audience here is really two parts. One, we should really think about, or everyone should really think about, why is space important to them. And the follow-up question that you should kind of like focus on is why should we care about space sustainability, right? Why should we keep space free of threat? And that's all for me today. And thank you for listening to me. And over to you, Paul, now.
Excellent. Thank you very much, Gurpreet. Really appreciate this. Looking beyond space debris, of course, it's the #1 issue. Well, I, of course, like all of these initiatives that we're learning about, but next we want to look to the future. So Costa, turning to you to learn about this new competition that we've got underway to design the flight school of the future. Please share some of the guidelines you have for this.
So hello, everyone. Can we see the next slide? So what WISA is doing here is moving to action, and we're hosting a design competition, student design competition for the flight school of the future. And this is a call for participation. And also, if you have students or if you're interested to participate, please join us. Next slide, please. So the objective here is, right now, we're trying to push the aviation sector towards meeting the sustainable and high performance and environmental goals as any other industry sector. And the question is, how can we take our flight schools and turn them to beacons of sustainability and innovation in the world of aviation? Therefore, we decided to launch an international student design competition where we're putting students together to provide us ideas and visions for how can we turn our buildings to sustainable centers. Now, the idea here is, while aviation, when you think aviation, you think up in the air, it's important to understand that there are facilities down the ground, and the intention of these competitions start from the ground up. Also, we're planning to share all the information with the public in a form of open source to also impact the designs of future schools around the world and not just in Canada. So our main focus here is sustainability. And by sustainability, I'm referring to economic, social, and environmental. And we're designing the request for design of 2 main buildings, which is the main institutional building, the school, that needs to be net zero and carbon neutral, and also a hangar that will be used for aircraft maintenance that will be also need to be net zero and carbon neutral. And the idea here is to set an international paradigm. Next slide, please. Now, of course, we wouldn't be able to do that without the support of our sponsors. Therefore, we do have awards for the three winning teams. A total amount of awards goes up to 8,500 Canadian dollars. And major sponsor, of course, is WISA, is the Flight Aviation School here in Waterloo, ALCIM, and of course the International Regional Airport in Waterloo. And we already launched the competition. The submission deadline, in case you're interested, if you know someone that can actually contribute in this ideas competition, is May 9th. We're gonna have a committee where it's gonna review the results, and we're gonna announce the official results on June 24th, which is the WISA annual meeting. Now we have a very interesting jury of world-renowned experts, many of which are professors or faculty members of our university, but we also have key members of our industry that will provide input and judge and critique the projects. Next slide, please. So that is all. Now, again, if you want to know more, there is a link here. Feel free to visit our website for more information. If you do have students, or if you know, or if yourself is interested to participate, please join us. And we hope to see you in this competition. Paul, back to you. Paul, you're muted.
Excellent, thank you. And linking us back to the website at WISA for details, and we encourage everybody to encourage their students and to contribute. Looking forward to the exciting ideas that come forward. So thank you to all of our presenters. I want to just start with a very quick question to each of you. The first, of course, we know these are complicated systems that you're all working with, but what's at the top of your list of the challenges that are faced? We've got industry and academic groups here together today. And so what are the challenges that we should be trying to solve? So I would just ask for the quick 1-minute response from each of you. We'll go in the same order that you presented to say, what is the top challenge that you are facing to advance the cause that you are working on? So perhaps we could start with Catherine. What's the biggest challenge that you're facing?
Battery management and duration of the batteries.
I think you're in strong consensus that people are agreeing with you there. Absolutely. Chelsea Ann, what would be at your top of the challenge list?
Well, I think that the biggest challenge right now for the airline level to become sustainable is definitely using sustainable aviation fuels. Of course, like Xianguo is going to know more about that than I know right now. But I know when I was doing my research, it's currently like 200 to 700% more expensive than the current fuel that's used. And like, if we were able to use biofuels, we could use it as a drop-in substitute, right? We already have the fuel lines, we already have the fuel trucks, but it's so expensive right now. So yeah, I hope that, innovation continues and we're able to have a more affordable solution there. But I think that's the biggest challenge right now at the airline level.
I think, again, a lot of consensus with you on that. Kevin, what's your biggest challenge?
Oh boy, you asked a good question, but for Catherine, I'll give you an answer to yours. The battery management systems and the life of the batteries, it's coming. I can guarantee you that on the diamonds. But when you talk about challenges, I'm not a singular person, let's just say, and I don't work that way. So I don't really want to talk about the biggest challenge, because there are several, and I could go down a long list of them. And I'm not sure that that's necessarily directly answering your question, but I don't think it also helps us very much if we just start to only look at the one problem. So we have to really take and I hate to use this word because it's being used too much, holistic approach. You have to look at all the parts of the problem,
okay,
I think
happy
that's
for you.
That's the challenge is getting us to be able to look at all the parts of the problem and find the right solutions, because only looking at one part isn't going to do us any good.
I think you're quite right, but if I accept holistic as your biggest challenge. Do you want to give us the first 5 that you list under that?
The regulatory agencies and their ability to keep pace with evolving technology, battery weight to the density, the power density ratios, technology in other parts of aviation that we need to consider, and how much energy that aviation as a whole uses, not just how much we burn while we fly. You should look at the bills we get for natural gas and our electric power bills. They're crazy for what we do. We need to look at that, and that's including all the aircraft manufacturers. The infrastructure, I think that was brought up by John Paul, the whole infrastructure that needs to be dealt with. That's a huge issue for us as we look towards building electric airplanes. How do our customers get the electricity charging stations that they need, right? So there's some just the tip of the iceberg.
Thank you. And I was going to try to justify my answer by saying I'm expecting different answers from around, but I agree with you. It does need to be holistic, but we need to also know where do we start to focus. Xianguo, do you want to jump in?
Well, I'm just going to reinforce what Chelsea and mentioned that we need a clean fuel, and then the propulsion technology that can utilize the clean fuel to power the airplane. And the technologies are basically there, but to implement it, you need a funding, you need government policy, regulation, standard codes to go along to guarantee the safety, the viability of the new technology. So there's a lot of things really aspect coming together. It's like not a simple question or simple answer to it.
Yes. Sorry, trying to simplify too much, I understand, but JP, do you have a challenge that you want to share with us?
Apologies, I'm muted. I would have said certification, but in truth, it's not that. What it really is the willingness to think outside the box. And I remember from Click and Clack, the Tappet brothers, when they spoke at MIT many years ago, said it should be unencumbered by the process. And so I think thinking creativity and trying to find that solution, the elegant solution, which we love so much in academia, which satisfies multiple dimensions, is really the thing that we need to really focus on. And I think that's the biggest challenge. It's just, we all would say aviation is going to take forever. If we take off that assumption and think creatively, I think we have a plan that will give you something in much shorter time frame than you normally would think. So I think the ability to think creatively and with unfettered is probably the biggest challenge.
I love that, because we so love to do what we did last year again and again. So outside the box, very good. Gurpreet.
Yep. Well, I guess if I were to put my finger on one thing, that would, well, for me and the topic would be data. It's really hard to get data because space and defense are kind of like put together, and agencies don't want to tell us what they're putting up in space. Manufacturers don't want to tell us what are they putting in their equipment, in their materials. So a lot of times it may feel like it's really dark out there and you're really starting in like no man's land. But I guess that's the fun of research. So data would be my answer. Thank you.
No, thank you. Of course, as an academic, I love the data answer. We want the data to analyze, absolutely. Now, I think Costa has had to go to class. Are you still there, Costa?
I'm still here, yes. And I couldn't agree more than with all the speakers. Now, I will also add here, despite the fact that it is not the most important, and there were some more important aspects that were addressed by previous speakers, is also the fragmentation of our industry and also the fact that we work in silos. And it's about time to start looking into how we exchange ideas and solutions from the energy sector to the building sector to aviation sector. We all need batteries. We all need to switch to renewables. And there are solutions that can fit and solve all our problems. And instead of working individually and in silos, Maybe it's about time to bridge these silos and work all together to solve the same issue.
Oh, I love this answer. You've set me up perfectly. The next question I was going to ask was about cross-sector collaboration. What are the best opportunities for us to get out of the silos and start working with others? And so it's sort of reverse question. Who would you most like to work with other than, you know, your neighbors in the same department? And perhaps we just go in reverse order. Costa, who would you most like to work with to have this broader perspective?
So it's very obvious I'm coming from the civil and architectural world, the building construction world. And I do see a lot of synergies with the energy sector and also aviation sector. That's why I'm here today.
Excellent. Gurpreet, who would you most like to work with outside of your usual cohort?
Yep. No, that's a good question. Yeah, like I think my usual cohort is very technical. But well, my dream team could be lawyers or policymakers, because you know, space is a global phenomenon. It is an international problem, space debris. So people who work on policy and law side of things. So that would be my answer.
Absolutely. JP, who would you like to be working with?
Well, you know, I think a lot of these problems require law, policy, and engineering. And in fact, those three disciplines are a recursive loop in any kind of development of any technology. So I think we need to get that loop in full gear.
Excellent. Xianguo?
Oh, well, we're in engineering, so I actually work with a broad range of collaborators and partners, from mining company providing the raw material to the material processing, refining, to the design fabrication, and to the final product, you know, the integrators. And then we also interact with the user community to get feedback on the product performance and the design features. So this has been kind of a circle we've been going. So it's a very broad range of collaborators we've been working with.
Thank you. Kevin?
You're muted.
Kevin, who would you, I suppose, like to collaborate with?
Yeah, I always got to remember that. But Costa, you brought up a good point about, you know, working in silos. But, you know, if you ever come up with an idea of how to stop working in silos within our own company, we might actually make headroads into working out, not working in silos across the industry. Right? But in terms of, I think for me, it's the other parts of the transportation sector and other areas of the academic and science and research community that's working on this more or less the same technologies, right? It doesn't have to be just in aviation that we look at it. We should be looking at what everybody else is doing and seeing how we could manage it.
No, absolutely. And what you mean, people don't automatically vaporize into and out of the airport? They have to use other means to get there as well. Very good. Yep. Chelsea Ann, who would you most like to have on your team?
Honestly, I want to have everyone who's here on my team, because there's all these initiatives and procedures that we talk about to save fuel and save emissions in aviation. But when it comes down to it, most pilots are not on the same page. Like, I still have conversations with pilots who are sitting beside me who ask me, so climate change is real? Like, that exists? So having people who are, you know, more respectful of what we're trying to do and trying to stick with the procedures and descending in a certain way and flying in a certain way to save emissions. Like, I wish I had more pilots like who are aligned with that.
Thank you. Well, it's a challenge to keep working on. Catherine, who would you most like to work with?
Well, I think that we have a lot of silos just within aviation itself. I think that we can learn a lot from gliding, from the small side of aviation, and from the airlines. And I think we need to bring all of those groups together and pick the best of it. At the risk of promoting Kevin's company, both Diamond and Grob have become very successful aircraft manufacturers, and both of them have their roots in gliding and use composite technologies that have been around in glider manufacture since the 60s. But you don't see a lot of that on the operations or training side yet. I think as we move towards electric aircraft more efficiently, and perhaps gliding and other forms of aviation can help us learn that.
No, that sounds excellent. I think like the winglets, even in terms of wing design, also had early initiatives on the gliding side too. But Kevin, in the Q&A, you might have noticed there's lots of interest in your talk and concern over the infrastructure for charging at London and elsewhere and how fast it can be. Do you want to add any details from our audience to talk a little bit about the charging infrastructure and what Diamond is hoping to see?
Yeah, looking at the infrastructure was actually really important to us when we started to talk about going to electric airplane design. And that's one of the reasons we partnered with EP Systems out of Utah in the US, because that was something that was part of their philosophy. Their goal set was not only to develop the battery management system and the batteries themselves, but to provide the infrastructure. And so we're looking at a whole bunch of different ways right now in order to do that. And one of them being simply is, plug into your hangar right now. And we're trying to look at various ways to do that, to manage the different electric systems around the world. That's going to be a slow charge, unfortunately. So, an overnight charge, but we're also looking at fast charging systems, both permanent installations. And on my slide, you saw that, the charging station that was a permanent one, but we're also looking at a mobile version of that, which will actually be just like a fuel truck, and it'll drive around the airport and charge up airplanes, and it'll be a fast charge. And we're looking to go to 20 to 30 minutes for the charge on the aircraft. And that truck will actually be utilizing the expired batteries that will come out of our aircraft, because there's only going to be a certain life to them. That's the reality of it right now. The batteries only have a certain life, at least able to be used for aviation purposes. So we're already looking at also, building that infrastructure to recycle the batteries and reuse them.
Excellent. Again, I like that multiple life of extending the life of the battery from having multiple uses once it's no longer to aviation standard to other uses is excellent. I also wanted to open up, would anybody on the panel like to ask somebody else on the panel a question? Encourage the conversation that way. And perhaps Valerie can watch for where hands go up. Everybody jumping to go first? Gurpreet.
Right. Yeah, I guess. Why won't I start first, right? Well, we are talking about a lot of manufacturing here, and I do manufacture for an aerospace company as well. So how do you, I think, what would be the challenges that you could feel, and I think there's multiple people on the panel that can take this question, what would be the challenges that you guys feel to basically convince the upper management or your peers that, for one, climate change is real? Second, how would you go about treating that in your organization? So I don't know who wants to take that question, but that's what's popping up in my head.
Feel free to unmute and respond.
Right. The money talks, and that's how you approach it. Right? You prove to the businesses, you prove to the government that there's money in this, and the reality is that this developing technology there's $1 trillion business opening up in this, and it's not just in building new airplanes. It's building new technologies. It's building the infrastructure. It's building the engines, the airplanes, everything. And there's a lot of money available, and what I don't think a lot of people realize, there's also a lot of capital pent up in the system that people are hoarding onto, and they're looking for places to put it. So I think that's the job to do, is to convince the people that have the money that there's reasons to spend it, and it's going to be good for them and good for everybody else around them too.
I spent the last 5 years or so doing a lot of flying for an organisation called Airborne Research Australia in Adelaide, who use echo demoners for scientific research. They're a not-for-profit, and of course most of the research is climate change. So I certainly didn't have to convince my bosses there about climate change being real. However, their biggest challenge was to get funding for any of this. Kevin, you say there's money out there, but they found it very difficult, certainly here in Australia, where there isn't perhaps as much support for climate change research as there should be, to hook into that. Don't know how we solve that.
Yeah, from engineer point of view, basically anything you're trying to develop, it has to be good to individual consumer, to be cheaper, to be more convenient for their use. Just like this mobile electronics from BlackBerry to iPhones, you don't have to do promotion. People are going to jump into it. So that's what in engineering school or faculty of engineering, what we're trying to do is that to couple this clean energy technology with this economic, expectation or in a perspective such that you don't have to push it. People were coming to you, whether government, investor, or of consumers, basically. And in terms of, this climate is real or not, it's sometimes a taboo, sometimes it's kind of a belief people may have. But Paul and I know that we worked together going back almost 20 years back. We started Clean Energy, this movement, and Clean Energy Journal for publication, Clean Journal Conference, and so on. And Paul was one of the invited speakers in the first Green Energy Conference right from the beginning. That's almost like 20 years now. And so it's not just one or two, there's a lot of research around the world agree with us. And this has been, growing in the community. And we have to do a bit of, education, information, dissemination that get to some of the hardest corner of the world. Somebody have their own belief, they just don't change, which it's okay. People have their own idea, but they're going to realize the reality. And if something turned out to be cheap, more convenient to use, doesn't matter what they believe in, they will come in with us. So.
Excellent one. Thank you, Xianguo, for being such a champion for green energy. And again, that persistence, it's not the first year, it's not the first decade. We just need to keep going. And the good news is we are getting better. The bad news is we're not improving fast enough. So we need to accelerate this rate of change. And so I'd like to thank all of our speakers today, but I'll give you one final chance to think about what final thought you would like to share with each of us. And to me, it's the importance, thank you all for being on time, the importance of multiple voices. We want to be able to say, yes, we need to recognize there are many issues on the table. We need to recognize there are many actors. We need to go beyond our normal little bit of a silo that we typically work in. Bring the team together, and that I see as the spirit of WISA. We want to try to bring researchers from all across the university, industry from its many aspects, from government from the policy side. The idea is to exchange ideas, brainstorm about solutions, think outside of the box. How can we improve to do it better next year? And I love that new energy that our students, of course, bring. We have these challenges, we have these new opportunities. So that's what gives me a great sense of confidence. And thank you for joining us today. But let's go in our reverse order of speakers. And Gurpreet, what is the takeaway that you would like to share with us as we move towards ending the webinar today?
Yeah, of course. And thank you for picking me the first, right? I guess my take-home message would be for everyone to realize that space is important for us, and let's not threaten it, which can threaten our future as well. Thank you.
Excellent. JP.
Well, the thing is that in everything in the world, you got to make it a win-win for everyone, a win-win-win. And so when we're doing the work on the CDA, it was all about emphasizing the airlines, the economic benefits of it in terms of reduced fuel burn. And now when you think about our hydrogen airplane that we're building and our solution, we've shown the airlines that the CASM, or CASK if you're doing in metric, are actually lower with a hydrogen electric airplane. And so I think finding that win-win where it wins on the economics and it wins on the environment is the right thing.
I love the solution. Very good. Xianguo.
To summarize in one kind of a short sentence, the energy system has been evolving since the beginning of human civilization, and I believe is going to end up with the so-called circular energy economy. The energy harvesting from harvesting to utilization in the entire process, there's nothing I throw away into our environment, whether it's the water, ground, or atmosphere. And that's the kind of a clean energy circular system I call energy system 4.0, looking at the historical development. So that's something else we can talk in another hour. So thank you.
Very good. Kevin, on to you.
Sure. I'll answer it this way. I gave a talk to students at Ryerson University a few years ago, and I was hoping to be able to continue doing such things, but unfortunately COVID kind of slowed stuff down. But one of the things that I talked about in the sustainability thing was to talk to them about what an engineer's responsibility is, the basic responsibility of engineer. And you know, when you go through school and when you get your job, and the big thing you learn about is protection of public safety. And then I started to talk about sustainability and what that meant and how we would look at it from an engineering and an aerospace application. At the end of the presentation, there's a lot of questions, a lot of really good questions. But then at the end, one of the students came up to me and said, you know, you talked about the responsibility of engineers to protect the public. So why are we where we're at? Why do we have all these problems? I didn't have an answer. But so that's what I challenge everybody here, not just the engineers in the audience or the student engineers. That's the challenge. If our responsibility is to protect the public, we have to change our way of thinking, right? And look beyond the immediate future, look to the future, look far into the future. What are we choosing to do today? And how will that affect our great-grandchildren, our great-great-grandchildren? And that's how we truly protect the public.
Excellent. Chelsea Ann.
Wow, following that, my goodness. For my presentation, the takeaways, I would just say that, you know, sometimes it doesn't feel like airlines are doing anything, but we are, you know, trying to do the more sustainable approach when it comes to routing and using efficient aircraft. Yes, of course, it saves us dollars as well. But I do think, yeah, that the implementation of biojet, biofuel would be necessary for airlines to sufficiently reduce their emissions to where our goals are. And then otherwise, of course, we have the electric aviation in the smaller aspects, and that's a very real solution for things like flight training. I just wanted to talk about these questions that I saw just pop up. First one from Elizabeth: are the pilot-related issues age-related? I think that what she's trying to ask is, do people, like, is there a link with people who are older? And yes, it is. It's like people, mostly people who are a bit older, kind of set in their ways, and they just refuse to accept things like that. Another question from Maida about Corsia. And I did look this up the other day, and what I understand is that they don't have to offset based on 2019 because we went through COVID and there was such a drop. So there's no offsetting, I don't think, for the next 2021 year.
Thank you. And on to Catherine.
I think in order to affect change, we have to start at the grassroots. So I think that your emphasis on flying schools and your competition is a very good way to do that. I think where we're at the moment, we had a discussion the other day where we talked about the first iPhone and how the Alpha Electro was effectively that. It's not quite there yet, but it's one of the things that's going to change the conversation. And I think we're at that stage where electric aviation is not yet normalized. It's not yet as practical as we like, but it won't advance unless we get those early adopters and we get those schools using it, so that it slowly becomes the normal, and the more use it gets, the more development it encourages.
Thank you, Catherine, and thank you for being one of the early adopters. Of course, when we look beyond the first iPhone, you think of those first mobile phones, they were sort of huge shoe boxes you had to carry around, and just like the battery getting better over time. So thank you for being an early adopter, and we very much expect things to improve dramatically generation by generation. So I want to give a huge thanks to all of our participants, to our audience for joining us, for industry and researchers for participating, and hope that we can continue to stimulate many conversations on these multiple topics. And of course, WISA is happy to be one forum for that. So we are happy to remind everybody that we'll be having our WISA Talks 4. We want to invite everybody to come and join us on April the 6th. That'll be at 10 a.m. Eastern for our final talk of the academic term. And that'll be led by our founding director of WISA, Dr. Suzanne Kearns. And I love the topic. It's this broad future directions in aeronautical sustainability. So what are these significant challenges and opportunities? Because we want to, I confess, I love the message that one of our previous presidents of the University of Waterloo used to like to say. He said, universities are very good, academics are very good at defining problems and refining the definition of the problem. Waterloo wants to help offer solutions. And so that I really take as our mandate. We want to work together to help find solutions for these challenges. And we want to continue the conversation and invite you to come back to future WISA Talks. So thank you everybody for joining us. Thank all the presenters for staying on time. You did a fantastic job. I know it was short. We would love to dive deeper into all of these. So thank you for joining us today, and we welcome you to come back for a future round. Thank you, everyone.